Dear students, welcome back to a new mathematics session. In the previous session, we have discussed up to question number 27 from the miscellaneous exercise of chapter 7 integrals. In today's session, we shall discuss the remaining problems from the same exercise. Let's move on to the topic. Today, the first three questions, that is question number 28, 29 and question number 30. These three questions you will try it as homework and we will discuss the answer during the live session. Next we shall discuss question number 31. Integral 0 to pi by 2 sin 2x tan inverse of sin x dx. Let's take this one as I, and integral 0 to pi by 2 sin 2x, we know the formula, substitute as 2 sin x cos x into tan inverse of sin x dx. So next what we can do is, here there is a sin x is there inside of this tan inverse. Okay, let's take that one as t. Sin x we have assumed as t. When you differentiate, cos x dx is equal to dt will be coming. Change the limit. When x is equal to 0, t will be sin 0. Sin 0 is 0. Next is when x is equal to upper limit, that is pi by 2. T is equal to sin pi by 2. Sin pi by 2 is 1. So the limit is changed from 0 to 1. That is 2 into integral 0 to 1. So this 2 is a constant kept outside. 0 to 1. Here substitution should be very careful. Sin x is t, so that is substituted. Then cos x dx is there. You see here cos x dx, that is dt. Then tan inverse, it is written sin x. Sin x is t, so tan inverse t dt. Then integral tan t into tan inverse t. This portion we will take and we will do integration. Then we will move to the applying limits. Okay. Here when you check t tan inverse t, this is a product rule we can apply, integration by parts. But the problem is the order is not in proper format. So the inverse trigonometry is first highlight when we use. So we can just rewrite as tan inverse t into t dt. Now we can apply integration by parts. First one into, that is tan inverse t into integral of second. Integral of t is t square by 2 minus integral of derivative of first one, tan inverse t derivative is 1 by 1 plus t square, into integral of second, that is t square by 2 dt. Okay. Then here t square by 2 we can keep outside. Tan inverse t means just change the order. This one we wrote first and this one second. Minus here 1 is a constant, 2 is constant to the denominator, keep it outside, 1 by 2. Numerator is having only t square and the denominator is having 1 plus t square. So t square by 1 plus t square format, several times we have done this integration. Simple. But we can do is in the denominator what is there, same thing we can make it in the numerator. Denominator is 1 plus t square is there. Just to make that 1 plus t square in the numerator, what we have to do, we have to add 1. So 1 plus t square we have done. For balancing, just to subtract 1 because numerator we are having only t square. 1 we added, same way we subtracted also. Then we will split it this one. 1 plus t square by 1 plus t square minus 1 by 1 plus t square. First part as it is will be coming minus 1 by 2 into integral. 1 plus t square by 1 plus t square is 1 minus 1 by 1 plus t square dt. Quite familiar format, this one we have done several times this calculation. So t square by 2 into tan inverse t minus 1 by t into 1 by 2 into integral of 1 dt, that is t. Integral of 1 by 1 plus t square dt, that is tan inverse t. Integral of 1 by 1 plus t square is tan inverse t. Then t square by 2 tan inverse t, remove the bracket, minus 1 by 2t, minus into minus plus 1 by 2 into tan inverse t plus c. Now when you check denominator, everywhere 1 by 2 is there. So that 1 by 2 we can take as common factor. Again you see there are two terms which is having tan inverse t as common factor. So these two together we can do. 1 by 2 I have taken outside as common factor for all the terms. Then first and third term when you check, there is tan inverse t is common, that I have taken outside. Then you see tan inverse t is outside, 1 by 2 is outside, only t square balance. It's written. Here tan inverse t is outside, 1 by 2 is also outside, so 1 balance. Then minus, here 1 by 2 is outside, only t balance is written. Then when we substitute in equation number 1, equation number 1 means this is the one, okay. I is equal to 2 into 1 by 2. From here only we have started, okay. This is I we have stopped, and then from there we have taken only this portion and we have integrated. So that portion we can just mark it as equation number 1, okay. Equation number 1 we can mark Then when we substitute it in equation number 1, I is equal to 2 into, see, t into tan inverse t, when we calculated, we have got this one 1 by 2 into t square plus 1 into tan inverse t minus t, that is written, then applying the limit 0 to 1. That is, when we multiply this one inside by keeping the upper limit, you see that 2 into 1 by 2. 2 into 1 by 2 means it is just 2 cancel. And again here, when you apply the limit 1 square is 1 plus 1 is 2. 2 tan inverse t is 1. So 2 tan inverse 1. Okay, once again, try to do mental calculation. Okay, each and every step, if you write and give, it takes a lot of time. If you have practice, then mental calculation is better. When you multiply these 2 inside, 2 into 1 by 2, 2 cancel. Then this applying the limit means 1 square plus 1, that is 1 plus 1 is 2, tan inverse 1, that is written here 2 tan inverse 1. Then again same thing only here, minus applying the limit 1, okay, minus, then again when you multiply this one inside, 2 into 1 by 2, 2 cancel, and then 0 square plus 1, 0 square plus 1 is 1, then tan inverse 0, tan inverse 0 is 0, so entire term will be 0, minus again this term 0, okay. And the calculation steps I have reduced, purposefully I have reduced because it takes a lot of time when you do all the steps. Try to do some type of calculation mentally also, but if you feel it difficult, then you just write steps. That is equal to 2 into tan inverse 1, tan inverse 1 is pi by 4, minus, here only 1 is there, then this all 0. Then here 2 and 4 we can cancel, and 2 and 4 cancel means the denominator will be having 2. So 2, 4 cancel and will be having 2. Then pi by 2 minus 1. Pi by 2 minus 1 is the answer. Next we shall discuss question number 32. Integral 0 to pi x tan x by sec x plus tan x dx. When you see here the function, it is not in any one of the non format. So what we can do is just we can see the limit here 0 to pi. 0 to pi means just we know there is a property, that is integral 0 to a f of x dx is equal to integral 0 to f of a minus x dx. So this property we can apply. So we know the algorithm. First we will take that one as I, and equation number 1 we will put, and then we will apply the property I is equal to integral 0 to pi f of a minus x dx, means x will be replaced, substitute as a minus x, upper limit is pi, so pi minus x into tan x replaced with the pi minus x, sec x replaced with the pi minus x, tan x replaced with the pi minus x dx. Some formulas are there, just we can apply. 0 to pi, pi minus x into tan pi minus x. Tan pi minus x is minus tan x. So tan 180 minus x. 180 minus x means clearly it is in the second quadrant. Second quadrant means there is tan is negative. So minus tan x will be coming. And sec pi minus x. Pi minus x also when we check here, sec 180 minus x, that is in the second quadrant. Second quadrant sec also negative. Second quadrant only sine and cosec is positive. And when you check here tan pi minus x, same thing, it is in the second quadrant, it is negative, so it will be coming as minus tan x dx. Then 0 to pi, here minus we can take outside, minus of pi minus x tan x. Then in these two also there is a minus sign common, minus of sec x plus tan x dx. Then I is equal to integral 0 to pi. Here you can see minus minus cancel. Then pi minus x tan x by sec x plus tan x dx, label it as equation number 2. Little bit of work is there here. After doing or completing all the simplification, then label it as equation number 1. Sorry, equation number 2. Then we know the algorithm. We have to add equation number 1 and 2. 2i, I plus I is equal to 2i is equal to integral 0 to pi. There is common LCM is there, sec x plus tan x we have taken. Then first term there is numerator x tan x plus second term when we remove the bracket pi into tan x minus x into tan x. So while comparing with the previous questions, now the steps are reduced. Some steps we have reduced because we will be able to do it if you practice some calculations mentally. So that's what some steps we have avoided. LCM taking all those steps are avoided. And here we are removing the bracket also, same time we are doing. Okay, not an issue, just keep little bit of concentration, that's all. Here when you check x tan x and minus x tan x, these can be cancelled, both the positive and negative terms. Then the balance will be 2i is equal to integral 0 to pi, that is only pi tan x by sec x plus tan x dx. Now I is equal to, this 2 will be coming here, then there is a pi constant outside, keep pi by 2 into this 2 is there, okay, denominator pi by 2 into 0 to pi tan x by sec x plus tan x. Then what we can do is here we can change it to sine and cos, because now also it is not in the non format. So what we only thing is that the comparing first and second means question format and this format, there is only x difference is there. In the question it is x tan x by sec x plus tan x. After doing this much work, we have got tan x by sec x plus tan x, not much difference, only 1x is changed. What we can do now, we can just change it in terms of sine and cos. So sin x by cos x by 1 by sec x, we know that it is 1 by cos x, plus tan x, we know that it is sin x by cos x. Take LCM, pi by 2 into, here cos x denominator is there, here cos x LCM taking means 1 plus sin x will be there. Cos x denominators cancelled. So only sin x by 1 plus sin x we have got. Okay, not necessary to write and do this type of calculation. You see denominator here cos x, here we take a common denominator cos x. The numerator will be 1 plus sin x. Denominators cos x cancelled, balance will be sin x by 1 plus sin x dx. Then pi by 2 into, just the previous question also we have done, denominator is having 1 plus sin x. What we have to do is to make the same numerator 1 plus sin x. So we have made here 1 plus sin x. For balancing, put a minus 1. Okay, then split it. This step also not necessary to write, but just showing here pi by 2 integral 0 to pi, split it. 1 plus sin x by 1 plus sin x minus 1 divided by 1 plus sin x dx. That is pi by 2 into 0 integral 0 to pi. This can cancelled 1 minus 1 divided by 1 plus sin x dx. Then do the integration separately. Pi by 2 into 0 to pi 1 dx minus 0 to pi 1 divided by 1 plus sin x dx. Pi by 2 into 1 dx, we know that is integration is x. Then apply the limit minus 0 to pi 1 by 1 plus sin x. What we can do, this is also not in the non format, so just to multiply the conjugate in the numerator and denominator. 1 plus sin x, when you take the conjugate, 1 minus sin x, just to multiply it numerator and denominator. Then pi by 2 into, here when we apply the limit, x replace with the pi, so pi minus 0, upper limit minus lower limit, pi minus 0 minus 0 to pi. Here numerator only 1 minus sin x, here a plus b into a minus b, 1 plus sin x into 1 minus sin x, that is a square minus b square, so 1 minus sin square x. 1 plus sin x into 1 minus sin x is 1 minus sin square x dx. Then pi by 2 into, here pi minus 0 is only pi, minus 0 to pi, 1 minus sin x divided by 1 minus sin square x is cos square x dx. So pi by 2 into pi minus integral 0 to pi, split it, 1 by cos square x minus sin x by cos square x. That is pi by 2 minus pi in 0 to pi, 1 by cos square x is sec square x minus sin x by cos x we will take and we will write as tan x. And there is one more cos x is the balance in the denominator, so 1 by cos x is sec x. Once again, sin x by cos x we are taking together and writing as tan x. And the denominator is cos square x, only one cos x we have taken, one cos x balance is there. So 1 by cos x we will consider as sec x dx. Now these two are non-format. Pi by 2 into pi minus integral 0 to pi sec square x dx plus 0 to pi minus into minus plus 0 to pi tan x into sec x dx. Okay, just as taking the integration symbol inside. Pi by 2 into pi minus sec square x dx integration is tan x. Apply the limit. Then tan x sec x integration is sec x. Apply the limit. Pi by 2 into pi minus, here applying the limit means tan pi minus tan 0. It's written here sec pi minus sec 0. Now pi by 2 into pi minus tan pi value is 0 minus tan 0 value is 0 plus sec 180 value is minus 1, sec 0 also 1. Okay, sec pi value is, sec 180 value is minus 1, then minus sec 0 is 1. That is pi by 2 into, here when you check 0 minus 0 is 0, then here minus into minus 1 minus 1, that is minus 2 will be there. So pi minus 0 minus 2, that will be coming as pi minus 2. So pi by 2 into pi minus 2 is the answer. Next we shall discuss question number 33. Integral 1 to 4 of mod x minus 1 plus mod x minus 2 plus mod x minus 3 dx. All modulus functions. What we can do is just we can take the integration symbol inside. Okay, there are three terms are there. Just we can take I is equal to integral 1 to 4 mod x minus 1 dx plus integral 1 to 4 mod x minus 2 dx plus integral 1 to 4 mod x minus 3 dx. They will test equation number 1. Then each one we are going to do separately. Take it as I1, I2 and I3. Now we know we have done before also this modulus functions integration by splitting the limits. Before that, let's take this function x minus 1, x minus 2, x minus 3 and equate with 0, and we will find out that breaking points. X minus 1, x minus 2, x minus 3 equating with 0 means we will be getting x is equal to 1, x is equal to 2, and here when we equate x is equal to 3 will become. Now let's take the first one. I1 is equal to integral 1 to 4 mod x minus 1 dx. Now by using the property of modulus functions, mod x minus 1 is equal to, here the breaking point is 1, x is equal to 1. So x greater than 1 equal, x greater than or equal to 1 means the function will take its positive value. X greater than 1 greater than or equal to 1 means positive means x minus 1. And if it is less than 1, smaller than 1, if you put, it will take the negative value minus of x minus 1. So this is the way we have to split. Positive value will take if x is greater than or equal to 1. Negative value will take if x is less than 1. Then we'll just take the integral, and I1 is equal to integral 1 to 4. You see that integral 1 to 4. 1 to 4 means it is greater than 1. Okay, our lower limit is 1 and upper limit is 4. Integral 1 to 4 means it is greater than or equal to 1. Less than or equal to 1 is not coming. So greater than or equal to 1 means only this portion will be coming. 1 to 4 x minus 1 dx. When we do the integration, integral of x dx is x square by 2. Apply the limit, minus integral of 1 dx is x. Apply the limit. Then here x square, x replaced with 4 means 4 square by 2 minus 1 square by 2. Taking LCM means 4 square minus 1 square by 2 will be minus. Here 4 x into x replace and put 4, that is 4 minus 1. 4 square is 16 minus 1, that is 15 by 2 minus 4 minus 1 is 3. And we take LCM here, 3 into 2 6. 15 minus 6 is 9. So 9 by 2 is I1 value. Next we take I2. I2 is equal to integral 1 to 4 mod x minus 2. When we equating x minus 2 with 0, we got x is equal to 2. So 2 is the breaking point. So we can split the limit as integral 1 to 4. So 1 to 2 and 2 to 4. 2 is our breaking point. Okay. So 1 to 2, then 2 to 4. That is the way we have to do. So by using the property of modulus function, mod x minus 2 is equal to x greater than or equal to 2 means function will take its positive value, that is x minus 2. And if it is less than 2 means it takes the negative value minus of x minus 2. Now 1 to 4 is there. 1 to 4 means we have to split it. Here we did not split because only greater than 1 portion only is there with us. That's why there is only one condition we can apply. But here it is not like that. Greater than 2 and less than 2 both are there in between 1 and 4. So we can split it as integral 1 to 2. 1 to 2 means it is less than 2. 1 to 2 means it is less than 2. Function will take minus of x minus 2 dx plus, then next is 1 to 2 and then 2 to 4. Greater than 2 means starting from 2 up to 4. The upper limit is 4. So integral 2 to 4. If you take integral 2 to 4, it is coming as plus x minus 2. So x minus 2 dx. Apply the integration, that is I2 is equal to integral 1 to 2. When you take this one, minus inside, minus x, minus into minus plus 2 dx, then integral 2 to 4 x minus 2 dx. That is I2 is equal to derivative of, integral of x is x square by 2. Apply the limit plus derivative 2 into 1 dx. The integration of 1 dx is x. 2 into x. Apply the limit 1 to 2 plus here x integration is x square by 2. Apply the limit 2 to 4 minus 2 into integration of 1 dx is x. Apply the limit. Rest now calculation is normal only. I2 is equal to minus, here 2 square is 4 by 2, then minus 1 by 2. When we take 2 as common LCM, 4 minus 1 by 2. Just you can do mental calculation, this one not a problem. 2 into upper limit minus lower limit, 2 minus 1. Plus here same thing, LCM and substitution together we are doing 16 minus 4, 2 square is 4 by 2 minus 2 into 4 minus 2, upper limit minus lower limit. You do it your own way, it's not a problem. If it is necessary to write some more step, you can write, it's not an issue. I2 is equal to 4 minus 1 is 3, there is a minus sign outside, minus 3 by 2, here plus 2 into 1, 2, then here 16 minus 4 is 12, 12 by 2 is 6, 4 minus 2 is 2, 2 into 2 is 4 minus 4. I2 is equal to minus 3 by 2, then 8 minus 4 is 4, 2 plus 6 is 8, 8 minus 4 is 4. When we take LCM, 4 into 2, 8, 8 minus 3 is 5, so 5 by 2 is I2 value. Next is I3, same thing only. When we take x minus 3 equal to 0, x is equal to 3, breaking point is 3. So in this limit we will break it as 1 to 3 and 3 to 4 by applying the property of modulus function. Mod x minus 3 is equal to positive x minus 3 if x is greater than or equal to 3. Negative x minus 3 if x is less than 3. Integration we are taking, we will apply the limit by breaking it greater than 3 and less than 3. Less than 3 means 1 to 3 will be coming. So integral 1 to 3, take the negative portion, minus of x minus 3 dx, plus greater than 3 means from 3 to 4. So 3 to 4 means positive value x minus 3 dx. I3 is equal to integral 1 to 3, remove the bracket, minus x, minus into minus plus 3 dx, plus integral 3 to 4 x minus 3 dx. Then integral 1 to 3 minus x dx, then just elaborated this one, okay. This type of calculation we did not do here, and if you feel this is convenient, just you go with that, it's not a problem. Here some steps we have avoided, but here it is not. Then minus x integration, then again integral 1 to 3 3 dx, again integral 3 to 4 x dx, then minus 3 to 4 3 dx. Then I3 is equal to minus of integration of x is x square by 2 plus 3 into integration of 1 dx is x, apply the limit, then x integration is x square by 2, apply the limit, minus 3 into integration of 1 dx is x, apply the limit. Then here 3 square, that is 9 by 2 minus 1 by 2, taking LCM, 9 minus 1 by 2 plus 3 into here, apply the upper limit minus the lower limit, that is 3 minus 1. Here again the same thing, 4 square is 16 by 2 minus 3 square 9 by 2, taking 2 LCM, 16 minus 9 by 2, minus 3 into upper limit minus lower limit, that means 4 minus 3. The 9 minus 1 is minus 8, minus is outside, okay. 9 minus 1 is 8, this minus outside is there, so minus 8 by 2 plus 3 minus 1 is 2, 3 into 2 plus here 16 minus 9, that is 7 divided by 2, minus 3 into 4 minus 3 is 1, that is equal to, here minus 8 by 2 is minus 4, and here 6, 3 into 2 is 6, and here minus 3. Then little bit of work is there, minus 8 by 2, minus 8 by 2 is minus 4, minus 4 plus 6, minus 4 plus 6 is 2, then 2 minus 3, 2 minus 3 is minus 1 plus 7 by 2, taking LCM, 2 into minus 1, that is minus 2 plus 5, minus 2 plus 5 is minus 2 plus 7, minus 2 plus 7 is 5, so 5 divided by 2, that is I3 value. Only thing is that just add these 3. I is equal to, first value is 9 by 2 plus 5 by 2 plus 5 by 2. 2 common LCM if you take, 9 plus 5 14, 14 plus 5 is 19 by 2. This is the answer. Next we shall discuss question number 34. Prove the following exercises 34 to 40. 34. Integral 1 to 3 dx divided by x square into x plus 1 is equal to 2 by 3 plus log 2 by 3. So this one, just not like the previous question, we need to prove this one. Means right hand side we have to bring by solving the left hand side. Okay. This one, when you see the left hand side, it is quite clear. It is by using partial fraction. That means 1 divided by x square into x plus 1, we can take it as a divided by x plus b divided by x square plus c divided by x plus 1. Then we have to take the LCM and we have to multiply it, and we need to solve that particular statement for getting a, b and c. After that you have to resubstitute and do the integration. So this portion you will do it as homework. Next we shall discuss the 35th question. Integral 0 to 1 x into e raised to x dx is equal to 1, that we have to prove. So applying product rule of definite integration, x e raised to x, that is what, x is algebraic and e raised to x is that exponential one. Okay, so by using eyelet the order is okay. First function into integral of second, first function is x, integral of second, that is e raised to x, integral is e raised to x. Then apply the limit 0 to 1 minus integral of derivative of the first one. Derivative of the first one means derivative of x with respect to x is 1. Then integral of second is e raised to x, that is e raised to x itself dx. Then apply the limit here 1 into e power 1, that is e power 1 is e minus 0 into any quantity is 0 minus integral 0 to 1 into e raised to x is e raised to x dx. That is e minus integral of e raised to x is e raised to x itself. Apply the limit 0 to 1. So e minus e power x replace with 1, e power 1 minus e power 0. Okay, minus e power 0 will be coming. Then when we remove the bracket, what will be coming? E, then minus e, minus into minus plus e power 0. Okay, if you want I will just show you that one. So here e minus, if inside the bracket only it is coming, upper limit to minus lower limit, e minus e power 0 will be coming. Okay. So when we remove the bracket only, what will happen? This portion will be coming, e minus e, minus into minus plus e power 0. So e minus e is gone cancelled and e power 0 is 1. So that is what our right hand side, hence the proof. Next we shall discuss the 36th question. Integral minus 1 to 1 x power 17 into cos power 4 dx is equal to 0. So what we can do is, first we can check whether this one is an odd or even function. Let's take this one as I, and f of x we can take. F of x is equal to x power 17 into cos power 4 dx. Because the right hand side it is showing 0. That means simply we can check whether the function is odd or even, because we can use that property if it is an odd function means. Okay, then for checking odd function, what we can do, f of minus x we have to calculate. F of minus x means replace this one with the minus x. So minus x the whole power 17 into cos power 4 of minus x. Then minus x power 17 is minus x power 17 only. Cos of minus x, cos of minus x is cos x itself, power 4. So now you check here, minus is outside. X power 17 cos power 4x is f of x. So minus f of x is coming. So minus f of x, if you want you can write it here. This will be equal to minus f of x. Okay. Since we are getting minus f of x, then we can say that f of x is an odd function, because f of minus x is equal to minus f of x we have got. We know the property that if f of x is an odd function of x, then integral minus a to a f of x dx is 0. Here you can check integral minus 1 to 1 x power 17 cos power 4x dx. We can write it as 0. Okay, so first of all you have to get an idea that how to check this one. Okay, we need to proceed for checking this odd or even function. How will we identify? See, by using this property, because minus a to plus a format it is there, and after all right side there is 0 also. We need to get an integration 0. So these are the two hints. Okay, by using these two hints we can choose that this is the method. Next we shall discuss question number 37. Integral 0 to pi by 2 sine cube dx is equal to 2 by 3. We need to prove that integral 0 to pi by 2 sine cube dx is equal to 2 by 3. So here we can change sine cube dx by using the identity sine 3a is equal to 3 sine a minus 4 sine cube a. What we can do is, here we need to calculate sine cube a. Here there is a minus sign. To avoid that, bring this minus 4 sine cube a to the left side. That comes as plus 4 sine cube a. And take the sine 3a to the right side. That comes as sine cube a is equal to 1 by 4. Here 4 is there, that comes to the denominator. 1 by 4 3 sine a, then this take to the right side, that is minus 3 minus sine 3a. Okay, take this one to the left and this one to the right, and this 4 will come to the denominator. Substitute here integral 0 to pi by 2 sine cube dx is equal to integral 0 to pi by 2 1 by 4 3 sin x minus sin 3x dx. So we know the integral of this sin x. So 1 by 4 into integration of 3 sin x, that is 3 is a constant, keep outside. Integral of sin x is minus cos x, minus sin 3x integration is minus cos 3x divided by the coefficient of x, here 3. Apply the limit 0 to pi by 2. Then 1 by 4 into here minus we can take outside, that is minus 3 cos x, minus into minus plus 1 by 3 cos 3x 0 to pi by 2. Just to substitute the limits, that is 1 by 4 into upper limit minus the lower limit. That means minus 3 cos pi by 2 plus 1 by 3 cos 3 x replaced with pi by 2, 3 pi by 2 minus the lower limit, that is minus 3 into cos 0 plus 1 by 3 into cos 0. Lower limit is 0. Now here cos pi by 2 value we know. Now cos 3 pi by 2 value we need to calculate. Cos 3 pi by 2 is cos 270. That means 3 into 180 divided by 2. When you calculate, you will get as 270. Cos 270 we can write it as cos 180 plus 90. So 180 plus 90, that is in third quadrant. Third quadrant cos is negative. So minus cos 90 degree minus cos 90 degree. Cos 90 degree we know, cos pi by 2, that is 0. So the answer we will get as 0. Cos 3 pi by 2 value is 0. Let's substitute here. Rest all the values we know. That is 1 by 4 into minus 3 cos pi by 2. Cos pi by 2 is 0. Plus 1 by 3 into cos 3 pi by 2. Cos 3 pi by 2 we have calculated. That is also 90. So sorry, 0. So 1 by 3 into 0 plus here minus into minus plus. Then 3 into cos 0. Cos 0 is 1. Minus 1 by 3 into here minus into plus minus 1 by 3 into cos 0. Cos 0 is 1. Now 1 by 4 into here 3 into 0 0. Here also 1 by 3 into 0 is 0. Then 3 into 1 is 3 minus 1 by 3 into 1 is 1 by 3. So 3 minus 1 by 3 is coming. 3 into 3 9. 9 minus 1 is 8. So 8 by 3 will be coming. 1 by 4 into 8 by 3. Then the 4 and 8, denominator 4 and 8 we can cancel 2 times. So the answer will be coming as 2 divided by 3. So that is what our RHS, hence the proof. Move on to question number 38. Integral 0 to pi by 4 2 tan cube dx is equal to 1 minus log 2. This is what we have to prove. We have to prove this integration. When we do, after applying the limit, we should get us 1 minus log 2. That is our answer. So here 2 tan cube dx is there. First of all, we need to change this tan cube dx. So I is equal to integral 0 to pi by 4 2 tan cube dx we have to write. Then tan cube x we can split as tan x into tan square x. 2 is a constant, keep outside. 0 to pi by 4 tan x into tan square x. This tan cube x we have split as tan cube into tan. Then 2 into integral 0 to pi by 2 pi by 4 tan x into this tan square x. By using the identity we can write it as sec square x minus 1 dx. Then remove the bracket. 2 into integral 0 to pi by 4 tan x into sec square x minus tan x dx. Now when we check here, in 2 into integral 0 to pi by 4 tan x into sec square x dx minus integral 0 to pi by 4 tan x dx. We have taken the integrals separately. Now when we check here, tan x derivative is there sec square x. First of all, we will take this one outside and we will do calculation because it is easy. Derivative is there present here. Tan x integration we know that. So this one we can do it by substitution method. That is integral 0 to pi by 4 tan x sec square x dx is equal to, as I said before, we can go for substitution because the derivative of tan x is present here. Then put tan x is equal to t. When we take the derivative with respect to x, tan x derivative is sec square x equal to dt by dx. Derivative of t with respect to x, dt by dx. So sec square x dx we need, just cross multiply it. Sec square dx is equal to dt. Then when we substitute it back, x is equal to 0 means the lower limit when we substitute, when x is equal to 0, because we need to change the limits also. When x is equal to 0, t is equal to tan 0. Tan 0 is 0. Then when x is equal to the upper limit pi by 4, t is equal to tan pi by 4. Tan pi by 4 is 1. So the limits changed as 0 to 1. Then find out the value of 0 to pi by 4 tan x sec square x dx. That is equal to, limit is changed 0 to 1. Then tan x we have substituted as t. Then sec square x dx is dt. Substitute 0 to 1 t dt. That is t square by 2. Integral of t with respect to t is t square by 2. Apply the limit 0 to 1. Then upper limit minus lower limit. That means 1 square by 2. 1 square is 1. 1 by 2 minus 0. 1 by 2 minus 0 is 1 by 2. So we have got the first part answer 1 by 2. Substituted back here. I is equal to 2 into 0 to pi by 4 tan x sec square x dx we have calculated, that is 1 by 2. Substituted. Then integral tan x is log sec x. Log sec x we have written. Then apply the limit 0 to pi by 4. That is, when we take this 2 inside, 2 and 2 denominator 2 cancel and the balance will be 1, minus this 2 when we multiply inside, 2 into log, apply the limit here, upper limit minus lower limit, sec pi by 4 minus log sec 0. That is 1 minus 2 into log, here 2 power 1 by 2, 2 power 1 by 2 minus 0. 2 power 1 by 2 minus 0 means how we have got in the sense sec pi by 4. Sec pi by 4 is root 2. Okay, so here we'll do little work here. Sec pi by 4 when we calculate, it will be coming as sec pi by 4. Sec pi by 4 is, when we do the calculation, it comes as root 2. Root 2 we can write it as 2 power 1 by 2. Okay, 2 power 1 by 2. So that's what it is written here. Log this term changed as 2 power 1 by 2. Okay, minus log sec 0. Sec 0 is 1. Okay, sec 0 is 1. Log 1 is 0. Then 1 minus 2 into log m power n. That is n log m. That means 1 by 2 into log 2. Minus 0, that means 0 is gone. Then when we multiply inside, this 2 can be cancelled. Finally we will get the answer as 1 minus log 2. This is our RHS. Next we shall discuss question number 39. Integral 0 to 1 sin inverse x dx is equal to pi by 2 minus 1. We need to get the answer as pi by 2 minus 1. So here when you check sin inverse of something is coming. Sin inverse of something means this something we can change it as sin of theta. So that means we have to replace x with a sin theta. That is the first part. Put x is equal to sin theta. When you take the differentiation, take the derivative with respect to theta. That means dx by d theta equal to sin theta derivative is cos theta. So when we rearrange, dx is equal to cos theta into denominator, here there is a d theta, will come here into d theta. Then change the limit when x is equal to 0. When x is equal to 0, sin theta is equal to 0. Sin theta equal to 0 means theta is equal to sin inverse 0. Sin inverse 0 is 0. Next is when x is equal to 1, we will be getting as sin theta is equal to 1. From here theta is equal to sin inverse 1, that is equal to pi by 2. Theta is equal to pi by 2 will be coming. So the new limits we have got as 0 and the pi by 2. Integral 0 to 1 sin inverse x dx, that is equal to in 0 to pi by 2, integral 0 to pi by 2. Here sin inverse of sin theta will be coming. Sin inverse of sin theta. Sin inverse of sin theta is theta. Then dx we have got as cos theta d theta. Then by using product rule or integration by parts, that is first one into derivative of second. So sorry, first one into integral of second. So theta into integral of cos theta is sin theta. Okay, then limit 0 to pi by 2. Then minus integral of 0 to pi by 2 is the limit. Derivative first, derivative of theta with respect to theta is 1 into integral of second. Integral of cos theta is sin theta d theta. Okay, once again integration by parts we have to do it. Theta into cos theta. Theta is the first function and cos theta is the second function. Here first function into integral of second. So first function is theta, integral of second, integral of cos theta is sin theta. Apply the limit minus integral of, limit is 0 to pi by 2. Derivative first theta with respect to theta. Derivative theta with respect to theta is 1 into integral of second. Cos theta integration is sin theta d theta. Then here when we apply the limit, pi by 2 into sin pi by 2. Sin pi by 2 is 1. Okay, so theta is replaced with the pi by 2. Sin again theta is replaced with the pi by 2. Sin pi by 2 is 1. So pi by 2 into 1 is pi by 2. Minus here 0 into any quantity 0. Then here integral 0 to pi by 2 1 sin theta d theta means integral of sin theta. Integral of sin theta is minus cos theta. Here there is a minus, here there is outside one more minus. So minus into minus plus. Sin theta integration we have got minus cos theta, that minus joined here came as plus, then cos theta balance, apply the limit. Then pi by 2, here pi by 2 minus 0 is pi by 2, then plus cos pi by 2 minus cos 0. Then pi by 2 plus cos pi by 2 is 0 minus cos 0 is 1. Then that is equal to pi by 2, 0 minus 1 is minus 1. So pi by 2 minus 1, that is our RHS. Next we shall discuss question number 41, multiple choice question. Choose the correct answer. Integral dx by e raised to x plus e raised to minus x is equal to, there are 4 options are there, we need to choose which one is the correct option. First of all, let's take this one as I is equal to integral dx by e raised to x plus e raised to minus x. So here there is a e raised to minus x is there, this one we can write it as 1 by e raised to x. The rest of the things are same, 1 divided by e raised to x plus 1 by e raised to x into dx. This dx is here. Then take here e raised to x as LCM. So when we take e raised to x as LCM means here you can see e raised to x into e raised to x will be coming. So e raised to x into e raised to x is e raised to x plus x, that is e raised to 2x. So when we take LCM, this e raised to x can multiply here, that comes as e raised to 2x plus 1. Here there is a denominator e raised to x is there, so nothing to multiply, so 1 will be coming divided by the common denominator e raised to x. What we have taken is e raised to x, we have taken as common LCM into dx. Now when you check here, e raised to x that is equal to integral, this denominator's denominator, e raised to x is in the denominator's denominator form, that means this will go to the numerator. So that comes as e raised to x divided by e raised to 2x plus 1. Now when we check, if you substitute e raised to x as something, then the derivative of e raised to x is e raised to x itself, that is there in the numerator. That means by using substitution method we can do it. So what we can do, put e raised to x is equal to t. E raised to x is equal to t, then we can go for taking derivative. E raised to x derivative is e raised to x itself, then that is equal to derivative of t with respect to x is dt by dx. So we need e raised to x dx. Take this one to the left side, that is e raised to x dx is equal to dt will be coming. Then I is equal to integral dx divided by t square plus 1 will be coming. Okay, so here e raised to x dx, e raised to x dx is dt divided by e raised to x, we have substituted as t, here 2x is there, so t square will be coming, t square plus 1. Now integral of 1 divided by t square plus 1, we know clearly the integral, that is equal to tan inverse t plus c, tan inverse t plus c. Here there is no limit and all is there, so nothing to apply here as a limit. Tan inverse t we can substitute back, t is e raised to x, that is equal to tan inverse of e raised to x plus c. Let's see here where it is, here is tan inverse of e raised to x plus c. So option A is the correct answer. Next we shall discuss question number 42. Choose the correct answer. Integral cos 2x divided by sin x plus cos x the whole square dx is equal to, 4 options are there, we have to choose the correct option. So here when we check, I is equal to, we can take this one as I cos 2x divided by sin x plus cos x the whole square dx. Now cos 2x, clearly we know the formula. Cos 2x we know that formula is cos square x minus sin square x. Substitute cos square x minus sin square x divided by sin x plus cos x the whole square. Now when we check here, numerator in the form a square minus b square. A square minus b square is a plus b into a minus b. That means cos x plus sin x into cos x minus sin x, by denominator is square is there, sin x plus cos x the whole square. So sin x plus cos x plus sin x plus cos x we can write. And when we check the numerator, there is sin x plus cos x, then 1 sin x plus cos x in the numerator we can cancel. Denominator will be coming cos x minus sin x divided by sin x plus cos x dx. Now when we observe this one very clearly, denominator's derivative is there in the numerator. Sin x derivative is cos x. Cos x derivative is minus sin x dx. So directly we can just write the formula and substitute, that's all. So integral of derivative is there in the numerator means f dash x will be there divided by f of x. F of x derivative is there in the numerator, that is f dash x. Dx is equal to log mod fx plus c. Okay, that is equal to log mod sin x plus cos x plus c. So when you check here, that is option B is here, log mod sin x plus cos x plus c. Next we shall discuss question number 43. Choose the correct answer. If f of a plus b minus x is equal to f of x, then integral a to b x into f of x dx is equal to, 4 options are there. We need to choose the correct option. So given f of a plus b minus x is equal to f of x, label it as equation number 1. This is a given condition. Now we have seen this as a property in definite integrals. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So that property we are going to use. Before that, consider this one as I is equal to integral a to b x into f of x dx. Label it as equation number 2. Then apply the property. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Sum of the limits minus the variable. That is, I is equal to integral a to b, x changes a plus b minus x into f of a plus b minus x. X replaces a plus b minus x. Here also same thing. Dx. This will be equation number 3. Then I is equal to integral a to b, a plus b minus x as it is will be coming f of a plus b minus x, that is there f of a plus b minus x, that is f of x. So this changes f of x dx. Label it as equation number 4. Now this one we have written by using 1, equation number 1. Next, adding 2 and 4. Equation number 2 is this one, equation number 4 is this one. So equation number 2 I is there, equation number 4 also I is there on the left side. I plus I is 2I is equal to, in the equation number 2 integral a to b. Here also equation number 4 integral a to b, that we can take common. Then x into f of x plus a plus b minus x into f of x, then dx. Okay. Then what we can do is, when you check here, f of x is common. Let's take out. Then integral a to b. Here f of x taking common outside means first term x balance, second term a plus b minus x balance into f of x dx. Now here there is x is there, opposite sign, plus x minus x can be cancelled. Then what we are getting is integral a to b a plus b into f of x dx. Integral a to b a plus b into f of x dx, that is 2I. What we need is I only we need. So I is equal to, here a plus b is a common, just we can take outside, a plus b into integral a to b f of x dx, little bit of rearrangement. Then what we do, just I we need to calculate. Take this 2 to the right side. 2 coming to the right side means it comes as divided by 2. That means a plus b is there already as a constant. A plus b divided by 2 into integral a to b f of x dx. This much only calculation. Now check here, where is this answer? So a plus b by 2, a plus b by 2 into integral a to b f of x dx, that is option D. So option D is the correct answer. Next we shall discuss the 44th question. The value of integral 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square dx is, there are 4 options. We need to choose the correct one. Let's take this one as I is equal to integral 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square dx. So here what we can do is, this 2x is there, that we can split integral 0 to 1 tan inverse of this 2x, we can split it as x plus x minus 1 divided by denominator is same into dx. Why we have split it? Because we need to bring it this one in the format tan inverse of x minus y by 1 plus xy. Then we can use this formula, tan inverse x minus tan inverse y. So x minus y by 1 plus xy, first term minus second term, that format we have to bring. It's quite simple here. X is considered as the first term, and there should be minus common we can take from these two terms. Then these two terms together we can consider it as y. Okay, that is what we are going to do. That is integral 0 to 1 tan inverse of first term is x. Then in these two terms minus if we take common, then we'll be getting as 1 minus x. This minus will go out, it comes as plus term. Then this plus x, 1 minus coming out means minus term will be coming. Plus term we can write first, so that's why 1 minus x divided by, in the denominator also 1 plus x into, if you take x common, it will be coming as 1 minus x dx. So this is now in the form x minus y by 1 plus xy. You see, x minus y by 1 plus xy dx. So I is equal to integral 0 to 1 tan x minus tan y, means first term minus second one. That means tan x minus, sorry, tan inverse of x minus tan inverse y. Tan inverse x minus tan inverse y. So tan inverse first term is x minus tan inverse of the second term, that is 1 minus x dx. So let it be equation number 1. Now you check the property here in limit when we check 0 to 1. So we have a property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Apply the property here. So I is equal to integral 0 to 1 tan inverse of a minus x, upper limit minus the variable. That means 1 minus x, upper limit is 1, here minus x. So tan inverse of 1 minus x minus tan inverse of again 1 minus x will change as 1 minus x dx. Once again tan inverse of this x will change as 1 minus x minus tan inverse of this x will change as 1 minus x. Already 1 is there, 1 minus of 1 minus x dx. That is I is equal to integral 0 to 1 tan inverse of 1 minus x minus tan inverse of, when you remove the bracket you can see 1 minus 1, that is gone, cancelled, then minus into minus plus x, so only x will be there. So tan inverse of x dx. Label it as equation number 2. Then equation number 1 and 2, when we add I plus I, that is equal to 2i. Integral 0 to 1 is there common, just we can keep outside. Then first equation tan inverse x minus tan inverse of 1 minus x, it's written tan inverse x minus tan inverse of 1 minus x. Then adding, that means plus second equation terms, that means tan inverse of 1 minus x minus tan inverse x. And when we check here, there is all opposite signs. You can see tan inverse x minus tan inverse x, minus tan inverse of 1 minus x plus tan inverse of 1 minus x. So 2i is equal to 0 we have got. That means I is equal to 0. So you can see here where is 0, the option B is there in 0. So option B is the correct answer. Dear students, today we have completed the miscellaneous exercise and also we have completed chapter 7 integrals. I request all the students to go through the entire exercises and solve the problems independently in a sheet of paper. While solving, if you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.